Hello, I'm Paul Tarao, and I will introduce you today to a new application that I developed. It's deployed on in the Streamlit cloud. It is DocDiver at Streamlit.app, and what the application can do for you is help you interact with a document that you have not seen before, like a research paper, and chat about the paper and summarize it and review it, all in a relatively simple interaction framework. Let me start by showing you. So I will drop a file right here. And by the way, this file is about another application that I have here, which is a little bit more general. It's called DeepLLM. It descends recursively and explores a concept like artificial intelligence, artificial general intelligence here. And it can do other things like, for instance, recommender systems, step-by-step guidance to achieve a goal, and so on. The paper that I will explore today is about this other application, and it will appear in a month or two at the FLOPS conference in Japan. All right, so let's start then. Here's my file, and I can even set a center of attention if I want that would focus the paper on a specific subset or topic in it, but I don't know yet. Let's assume that I don't know yet what that topic would be. So let me start by summarizing the paper. That gives me a first glimpse of what the paper is about. The current interaction was a bit faster because the system has a very nice caching mechanism that if I did that a few minutes ago and uploaded, then everything would show up instantly. Otherwise, it takes 30 seconds or so for most 15-20 pages scientific documents. And if you look at the summary, you would see that some of the words here are in green. They are the words that occur in the document, more precisely the words that occur in the salient sentences that I will show you right now. The salient sentences are extracted from the document by a graph ranking algorithm that uses also a vector store and semantic distances. This actually reuses some of the infrastructure that the paper itself presents, which is, if I would show it to you right here, it is actually the picture that you see here, okay? There is a vector store, there are some ground truth facts, there are recursor and refiners, there are even some synthesized logic programs that come out from this automated interaction with the LLM, and there are, of course, answers that at this point can also be turned into relations, subject-verb-object relations. But to get back to our story here, those would be then the sentences on which the summary that I showed you as well as a review of the paper can be generated. Let me generate a review. I hope it's a reasonably good one because GPT-4 is a relatively picky reviewer. Okay, let's see what it says about the paper. Well, so far so good. The paper presents an innovative approach to automating deep step-by-step reasoning in large language model dialogue threads. It introduces a method that combines recursive exploration of alternatives and expansion of details, and notes with semantic similarity checks against ground truth facts or oracle advice from another LLM instance. So this is the framework, in fact, on top of which the application itself that I'm showing you now is built. So after that, it goes over the strengths of the paper, the weaknesses, there are a few, and it even gives recommendations for improvement. If I have some time, I will still improve this paper. If not, we'll be moving to the next cool topic that's already on my mind. What you can see here is how much it costs in terms of LLM work. This is 4 cents for the work so far, so pretty reasonable. Well, let's chat about this paper maybe. And let me ask about applications, see if this is any use, and proceed. So we'll have very quickly extracted some applications of the paper. It answers that question, but I let the LLM take the initiative here, and what you see in the window on the left, what specific technologies or methodologies does the DeepLLM app employ to ensure the generation of hallucination-free focused knowledge? So that's generated by the LLM by kind of forcing the LLM to look ahead of what could come to your mind after you answer the question. I think whatever it comes out as answers is also improving. You see the answers here, pretty elaborate, and it means that this is possibly a useful app after all in the real world. Now you could let the LLM proceed in this, well, self-driving mode in which it generates newer and newer questions as it actually explores on its own the document. But of course, after doing a few steps, you might want to say, well, let me take over and maybe ask about something else related to the document once I decide that my focus of interest is different. For instance, here I could maybe just say, how is the vector store used? And let's proceed with new questions where I'm overriding what the LLM would spontaneously talk about, and we will see a new thread actually coming out that could be also put in self-driven mode and let the LLM explore it further, or it could be the user's initiative, what we are talking about. Some of the concepts that show up here, they are related to logic programming. The paper actually about which we are talking generates a logic program in which the recursive descent in the dialogue is actually cast. So I think the answer got here. The vector store is used in several key ways to support the functionality and efficiency of the system described. So it has semantic distances, it supports the knowledge base. We have something called abducibles, which are the hypotheses that you make as you advance that might be true or might not be true. And then you can check those hypotheses, of course, with facts in the vector store that you can get from Wikipedia or from some reference documents. So after you do this interaction, you might also want to visualize it, or to visualize the key concepts that are extracted. So for that, you could say, let's build a relation graph now, and we can proceed with that. And the relation graph would be also extracted from the set of salient sentences. You can zoom up or down with the number of sentences. You know, if it's a very long document, you might want to have a larger subset of it extracted in the form of salient sentences. If the document is maybe a typical 15-page research paper, then that's enough, maybe the default 100 sentences that I extracted. You have also a number of choices here. You can use GPT 3.5, which is a reasonably good LLM, less expensive a bit than GPT 4. And I'm using also a local LLM. In my case, that's Mistral, and it runs on a little Linux server nearby. That also handles reasonably good performance, at least for the main task, like salient sentence extraction, summarization, and the review. While this is running, because generating this graph and also displaying it might be within the 1 to maybe 3 minutes time. I didn't prepare this in advance. Let me show you the actual web page where you can fetch DeepLLM and everything that's related to it. So that's on GitHub in the recursive app in my GitHub repository set. And there are a number of other applications there that might be interesting on their own. You have here DeepQA, which is a recursive question generator, and then it explodes in a very similar way by making question-answer pairs, and then at the end it actually generates a grammar out of that, a definite clause grammar, which is a Prolog tool that could replicate the complete interaction without the LLM in the picture. So I think by now it all finished. That is the DeepLLM demo client. So the new addition to DeepLLM is kind of similar. In this case, it relates concepts by either ease links or just kind of semantic similarity, weaker links that would give you a reasonably good picture of what's generated from an initiator, a single prompt, in this case artificial general intelligence, scientific concept. But it can also predict its consequences. Let's make it, while we are talking about something else, predict what will be the consequences of this, and then we'll see some different output. So let's get back now to finally finished graph extraction, relation graph. And that relation graph is a bit richer in information because now we have a background, the document that I fetched here, the research paper in this case, and the visualization can be unwrapped, and you would see several links here. I also instructed the LLM with one of the prompts to do generalizations. I also extract SVO, subject, verb, object triplets from the text itself, also with the help of the LLM, in this case GPT-4. And I also use my own vector store for similarity links. So the combination of those would give me a reasonably rich set. Now, if I want to proceed again and refresh it here, I can also see it as JSON code. That's a bit more readable. You see the relations ready to be, of course, exported and used in a different program as you know, a knowledge graph builder or some ontology related work. You can also see it, if you want, as a Prolog program, ready to run, ready to make new inferences, symbolic inferences in this case, and then maybe come back after those symbolic inferences have been made and have another round of LLM interaction. You can see this very well as a multi-agent, symbolic and well, generative AI system working together. The toolkit that is provided in this DeepLLM framework is actually extensible, and it can be very easily customized to build multi-agent applications with it. But it's written from scratch. It doesn't use any of the more well-known frameworks like Llama Index or anything that could put together, or external vector stores or anything. It's all made from scratch. All right, I guess we can take a break until next time here, and I hope you enjoyed it. Remember to explore it yourself. You can go to docdiver.streamlit.app for this particular application, and you can go to DeepLLM-Streamlit.app to explore the original framework that can do, in this case, by now it computed a set of consequences of what would happen if artificial general intelligence would be enabled. You see, some of them are good, some of them create dilemmas, so you can explore controversial topics, political, scientific, quite easily with this framework as well. This is it for now, and see you then next time.